So after getting the overall AC equivalent circuit of the amplifier, we had established that there must be an input impedance which forms part of the resistances on the input side of the amplifier, which is in this specific case is made up of RB1 in parallel with RB2, and that in parallel with the resistance that will be measured from that point all the way to ground. What is that resistance? The fact that this is RB1 is in parallel with RB2 in parallel with that wall resistance, which is made up of R pi and some element of RE1, that means and VI is applied there. Voltage for resistors in parallel is the same, so that will be VI still, that will be VI still. So if we assess the amount of resistance that we have from that point to ground, we need to go from Ohm's law to establish VI. VI is made up of R pi through which flows IB. So that makes it B equal to R pi plus times IB. That would be the voltage drop across R pi plus RE1 through which flows IE and not IB. We know that IB is related to IE as beta plus 1 IB. So putting the two together, we get VI is equal to R pi IB plus RE1 beta plus 1 IB. So that would lead to VI over IB, if we put IB as a common factor and it goes on the other side, to be equal to R pi plus RE1 times beta plus 1. That means the resistance as measured from that point to ground is actually equal to R pi plus RE1 times beta plus 1. And it's all of that that is in parallel with RB2 and RB1 to form Z in or R in, which is the impedance therefore now is measured from there all the way to ground. Very important. Okay. Similarly, we have on the output side Z out or R out, which is the output impedance, sometimes capital R small o, which is the output impedance as measured from that point, looking from the output side basically, from V out point. So when you look from the outside, you see RC alone. So that will be normally RC. But that will be the ideal case because the similarity to what we said that there is an input resistance within the transistor when looking at the base, which is R pi. There is an input resistance within the transistor when looking from the emitter, which is RE. And we established that RE was related to R pi is R pi divided by beta plus 1. We demonstrated that. There is also an output this time. You remember for the other two R pi and RE I said input. This time I'm saying output resistance RO, which is observed from the collector side, which is the output side in a common emitter situation, and that's small r and O. Not to confuse with the output impedance capital R and O. Small r and O is actually caused by another voltage that we call Ailey voltage, Ailey, which is the name of a British engineer, and it's normally a very high negative voltage, but we're gonna take it magnitude. Sorry, it's normally a high voltage which is the magnitude of a negative voltage. We'll explain the early concept just now. And the fact that on the output, which is on the collector side, we've got IC, RO is therefore calculated as VA of I over IC. So RO is often very high. That's why in the ideal situation, we assume RO output impedance looking at the collector, between collector and the emitter, to be infinite. And if it's assumed to be infinite, then we speak about the ideal case. So in the ideal case, Z out ideal is just RC. But when we're not in the ideal case, we must provide you with VA, and you work out IC, then you can compute RO. Then when you look from that point into the output of the transistor, you will see RC now in parallel with RO. That's why the actual non-ideal Z out is RC in parallel with RO. Very important. Okay. That concludes the idea about input and output impedance in this specific case. Early voltage, as I said, is a concept that comes from the fact that by observing how VBE was changing VC was changed with respect to VBE. It was found out that for different IB values or beta values of the transistor, you will get different curves like that. If you were to project these curves in the negative side, you'll find that they all meet at a common point, negative point called VA, minus VA, sorry, in such a way that that magnitude of that negative voltage is what we call the early voltage. More concepts about the early voltage are developed through the Grob's textbook. Okay, so now we move on to the next element that defines an amplifier other than the input impedance, the output impedance, which is the gain.